A chill and shining evening to one and all present here. My name is E. Francie Hridayarani, and I have the pleasure of being your MC for today's webinar. This day is much awaited day in every engineer's life. All of us are united here and moved by a deeply felt sense that we urgently need to create a new and brighter world of hope. So I thank and welcome every one of you for our today's webinar on engineering employability and emotional intelligence, organized by Department of Electronics and Communication Engineering, Francis Xavier Engineering College, Tirunelveli. Prior, the world's greatest wireless connection. Let me invite Miss C. Gerlin Christina Grace, our final year ECE student, to start this event with holy prayer.
Prayer. Dear Almighty and ever loving God, we glorify your name. We praise you for this wonderful moment. We thank you for all the countless blessings that you have showered upon us. We have gathered here in your presence for this webinar session. As your word says, for the Lord gives wisdom, from his mouth comes knowledge and understanding. Bless and enrich our resource person with your knowledge, wisdom, and understanding to deliver the immense informative presentation for us. Bless the organizers, coordinators, and our HOD ma'am who helped for this webinar, and bless each one of the participants. Bless us, lead us, and guide us. May you bestow your blessings after this webinar so that we may go out and spread what we have learned. In the spirit of your love and generosity, we commit ourselves into your hands. We ask all these in the name of the Lord Jesus Christ. Amen.
Thank you, Gerlin, for your pleasing prayer. May we greet each other with a smile. A smile is a universal welcome. Now I wish to open this webinar with the lovable welcome from our beloved Professor and Head, Department of ECE, Mrs. J. Krista ma'am.
Draw near to God and He will draw near to you. Welcome and thank you for being here today for Industry Expert Series Exciting Session 6 on Engineering, Employability and Emotional Intelligence by Mr. Barnabas Muthu sir, Strategic and Innovative Supply Chain Technology Architect, Indian Institute of Management, Calcutta, Rider Supply Chain Solutions, New Albany, Ohio, United States. First of all, I would like to place my heartfelt gratitude to Lord Almighty for His manifold blessings and divine guidance on all of us. Next, I would like to record my sincere thanks to the management of Francis Xavier Engineering College for being with us, motivating us, and behind us in all our efforts. I would like to welcome Dr. Jaykumar sir for his constant support and directions for successfully organizing all our in welcoming our respected principal, Dr. V. Velmurugan sir, to this greatest gathering. We welcome you, sir. I feel extremely delighted in welcoming speaker of today's session, Mr. Barnabas Muthu sir, Strategic and Innovative Supply Chain Technology Architect, Indian Institute of Management, Calcutta, Rider Supply Chain Solutions, New Albany, Ohio, United States, who is with us from United States to share his knowledge, experiences, and expertise with us. We welcome you, sir. I would like to welcome the coordinators of today's event, Mrs. Niranjana Madam, Mrs. Chitra Evangeline Christina Madam, Mrs. Francie Hridayarani Madam, Assistant Professors, Department of ECE, for their commitment and dedication in connecting a distinguished resource person with us. I would like to welcome all the participants who have signed with us from academic institutions, industries, students across the states and across the globe to get practical insights. We would like to record that for today's exciting session, we have received 800 plus responses. We wish to congratulate all the participants for your commitment and active participation, and we wish you a fruitful session ahead. Thank you.
Thank you for your pleasant and graceful words, ma'am. Successful and unsuccessful people do not vary greatly in their abilities, they vary in their desires to reach their potential. One of such successful personalities is our chief guest. Now I invite Mrs. R. Niranjana ma'am, Assistant Professor, Department of ECE, to introduce our eminent chief guest and speaker of this webinar.
So, good afternoon, everyone. Mr. Barnabas Puttu sir is an electrical engineer by education, domain solutions architect by profession, and a supply chain technologist by passion. He currently leads the technology delivery team for Rider Last Mile and is responsible for vision, strategy, execution, and delivery of technology solutions needed to support business operations. He is a certified professional in advanced supply chain management from the Indian Institute of Management, Calcutta, and a certified Scrum Master from the Scrum Alliance. He is passionate about God, technology, and innovation. So we're deeply honored, sir, to have such a dynamic and successful person here with us this afternoon as a resource person. We thank you and welcome you.
Thank you for your brief introduction, ma'am. No one can go back and make a brand new start. Anyone can start from now and make a brand new ending. Let us start our brand new start by hearing the words from our eminent chief guest. Now I invite our chief guest, Mr. Barnabas Muttur sir, to deliver his speech on engineering employability and emotional intelligence. Over to our chief guest.
Good evening, ladies and gentlemen. I like to call you ladies and gentlemen because I always believe that as soon as you enter into a professional engineering college, you are engineers and you are professionals, and you are there to conquer the entire world. So I would like to start by thanking Professor Chitra, Professor Associate Professors Francie and Professor Niranjana, the head of the Department of Electronics and Communications Engineering at Francis Xavier, Professor Friska, the principal, and Dr. Vel Murugan and Mr. Jay Kumar, who's all here as part, who's been key people in putting this webinar together. And thank you so much for inviting me. It's a great honor. It's a great privilege to be with the student community. This is not my first rodeo with students, but it feels like every single time I talk to students, I get a fresh perspective. I get more and more learning from what you guys hear. But this is my first time doing it over the web. I usually prefer having a much more interactive conversation. I'm not a kind of a person who walks through slides and reads through every single information that is present on a slide. Rather, I would like to make it more interactive. But due to certain limitations that we have at this point in time, it's a boon and a bane. It's a blessing in disguise that we are able to connect from thousands of miles apart. But it is also limiting us from including that human factor of connecting with each other face to face, and me understanding what you guys are thinking, what you guys are, how you guys are expressing and responding to the conversation that we are having here. So with that laid out, I'm just going to talk about, it's going to be a very plain talk on what is engineering, what is engineer, what does an engineer mean, what does an engineer have to do, and talk a little bit about employability, right? I'm not going to be going too much into the details of what kind of job you would want to get into, or how do you get your dream job and all of that. But it's more around how do you use these 4 years of your graduate education, of your engineering education, to prepare you for the next 40 years of your career as an engineer. So let me start with asking you a question to think about. I do not know how many of you had really thought about this question. What does engineer mean, or what does engineering really mean? We all can go into Google and we can just type in who is an engineer, or what is a definition of an engineer, or what does engineering mean, and you would get variety of responses, right? One of the most intellectual and textbook definitions that you would get is almost a page long, and I'm not going to read it. That was defined in 1961 at the Conference of Engineering Societies. But if you are interested in understanding what that is, it's literally like more than 10 lines, and I don't think it's really my way of expressing what an engineering is. With no, I'm not critiquing whatever is defined as a professional engineer, but there are much more simpler ways of expressing who an engineer is. Is an engineer someone who does every single thing that's listed there in the definition of a professional engineer? Or is it someone who's represented in this little cartoon by Mr. Dilbert that I'm showing here, where he is a worker who keeps slogging and keeps working and working and working on all the mundane tasks, or doesn't work at all, or just pretends to be working? Or in words of my friends and words of student communities that I've been interacting with, especially in an Indian ecosystem of engineering education, one thing that I've constantly heard is like, yeah, an engineer is the one who can complete all the assignments and all the pending work before submission. An engineer is the one who constantly struggles to keep his attendance up, make sure that the attendance is above the listed criteria. Or an engineer is the one who can go ahead and present a project or a presentation at any time without any preparation. Or an engineer is probably the one who can answer a viva question during a practical examination, or a defense during a dissertation, or a project presentation, even if he or she does not know the underlying fundamentals or the underlying uh, basics around what solution is being presented or being worked on. Or the one of the most favorite responses that I get is like, an engineering degree or an engineering student is always capable of just studying the day before the examination and pulling it off in style and scoring a very good mark. Is that all engineering is all about? Is that all the 4 years of engineering education that we do to become an engineer all about? I don't think so. The way in which I look at engineering and the way in which I look at an engineer, and I'm very passionate about engineering. I'm very passionate about an engineer because I'm an engineer by education, and I attribute, second to God, I attribute every single one of my credentials and every single one of my growth path to the engineering education that I received, which made me think in a different perspective altogether. So, what is engineering? What does an engineer do? In my view, an engineer is, I'm just having some technical difficulties here. An engineer is a problem solver. An engineer is someone who can convert or transform a problem into a solution or an opportunity. And that's how a lot of opportunities have been created across the globe in this world, right? Someone saw a problem and they thought, okay, why can't I solve this problem by putting in some thought into it, some thought process into it, and follow a scientific method, but also apply an artistic creativity to it and arrive at a solution and make it an opportunity, make it either a business opportunity or make it a solution, or however we would want to transform. How has engineering transformed over the past few years? Or I should say, probably in the last uh, millennia. It's changed a lot over the years. The engineering industry is not what we used to think it is, right? It is no longer exclusive to constructing a bridge, or it is not exclusive to steam engines, where you say, okay, this is a mechanical engineer's job, or this is an electrical engineer's job, this is an electronic engineer's job, this is a civil engineer's job. Now, engineering is across all boundaries. Now, engineers have started to branch into everything from being cloud experts, but also getting into the basics of, be it building construction or material design, structural design, whatever it could be. And if you look at the evolution of engineering, or the evolution of how the industry has moved from the first millennium to the second millennium that we are right now in, it's it's changed a lot. We initially see what happened before the first industrial revolution in the ancient era, when there was a lot of focus around construction. If you look into the uh, first century or the second century, or BC, it's all about constructing constructions. We know about the beautiful designs and the constructions that are in Egypt with the pyramids and all that stuff. And when you go into the AD era, which is the middle era, where things started changing in the 11th and 12th century, there were a lot of brilliant innovations or inventions that were made. The clocks that we use today, the crankshafts that we use today, the suction pumps that we use today is all from that middle era. And that's what we have been trying to construct on and evolve from what was happening in that middle era. And over the years, what happened when we got into the 17th century and the 18th century, between the late 1700s and the early 1800s, manufacturing kind of evolved from focusing from manual labor, what was happening with animals and human labor, to an optimized form by using water and steam powered engines. So that's where the industrial revolution starts, which is rightly termed as Renaissance, right? And between the 17th century, the 18th century, and the 20th century, all of these were evolving when it hit the Industrial Revolution 2.0, or what we call as a modern era, the start of a modern era, which marks the invention of electricity and the commercialization of electricity. Once electricity came into place, everything was machinized, and we wanted to go and take manufacturing mobile. We created a bunch of industries. We were able to interconnect these industries, and electricity paved a major role into production concepts. We started building production lines, we started building assembly lines, and we found more ways to boost productivity. And through all of these different generations of industrial revolutions, engineering has always been a key. Be it on the construction side with civil engineering, be it on machines and making sure that we achieve the right productivity with the mechanics. It's engineering that played a role. And as we move further into a new age, which is the age of information, and that's when electronics, communication, and microprocessors, microcontrollers, all of that came into existence. So this was the latest industrial revolution that we've all been part of, right? This started in late 1950s, and what this brought up was incorporating more electronic and eventually a computer-based system, and bringing in more and more technology into our factories. During this period, if you learn about what happened during that industrial revolution, manufacturers saw a huge shift from analog to digital processes, from analog mechanical technology to a completely digitized processes, which was a start of what we call as digital transformation. And this was an exciting age, which got me into more on the technology side, which got me into engineering, right? So we're talking about rockets and turbojets, which propelled aeronautic engineering, which propelled rocket science, which propelled nuclear engineering out of bounds. And it was these three core uh, components of electronics which kind of merged that industrial revolution, the third industrial revolution, with what was much needed in the world. So it was microelectronics, telecommunication, computers, and software, which also led to the boom in needing more and more people who can work on the analytical side, who can work on building the software, who can work not just on building a software per se software, but who can also write code that can make hardware do the right job. So you all know the first search engine that was built in 1990 by Alan Emtage, and there's been a lot of roles that has been created since then. And there's a lot of open source code which has come along the way, which paves way for a newer generation of technologists, a newer generation of engineers, and a newer generation of industry. Oh, I'm still on the same slide as I mentioned. Okay, so I'm hearing feedback that you're not able to see my slides. I hope you're able to see my screen now. So, what I want to talk about and what I want to focus on today is going to be what is coming up in the future. What is the term or the buzzword that's floating around the industry called as the fourth industrial revolution constitute about. But before we get into most of those, I just want to talk a little bit about the previous or the era between the information technology age, which is the third industrial revolution, which I'd like to term it as Industry 3.0, to where we would want to be, which has now started, the fourth industrial revolution or the start of the future technology or the future industry. There is this intermediate space in the last 20 years or in the past 2 decades where we are focusing on women in technology. And there's a lot of things that's bringing in aspiring female computer scientists, women mentors, and initiatives that are focused very much on women being in technology. Why is there a lot of focus on women being in technology and engineering today? It is because the world needs a lot of engineers, and the world needs a lot of diverse engineers who are able to bring in a mix of the masculinity of engineering and also the feminine characteristics of engineering. And that's where women in technology play a huge role. And that's where there are a lot of non-profit organizations like Girls Who Code or She++ and all these different organizations, which is focusing more on building aspiring female technologists and female engineers and female computer scientists, etc. So, women, if you're hearing this, you are no different than the men who are in engineering, who've been doing engineering. So engineering, as they would say 20 years ago or 30 years ago, engineering is not for women. That's not the case today. Today there are a lot of women engineers who dominate the technology space. So, with that being said, I just wanted to lay out a couple of caveats or disclaimers as to what this talk is not about. I'm not here to give you a list of items to say, okay, you follow all of these, you check these boxes, and you're going to land on your dream job. No, this is not about that. And I would want to reset your expectations here. What this is not about is about training as well. I'm not going to be training you in any of the skills, and there are a lot of educated and highly qualified professors. There's a lot of other highly qualified personality improvement coaches who are there to train you on the hard skills and the soft skills, etc. So I'm not going to be training, or I'm not going to be doing any hardcore training on any of your skills or improving your skills. Nor am I going to list a set of jobs and I'm going to tell you how to get into one of them. But what I'm here to do today is to impart a fresh perspective that will help you to start on your path for success and make sure that you set your foot on the right direction and take one step at a time, left foot, right foot, and achieve success at the mid or end of your professional career and have happiness and have satisfaction about what you're doing and have that understanding of where you would want to go as a professional and what you're called to do. That's what this conversation is all about. I'm going to be talking a little bit about the industrial revolution, the fourth industrial revolution, and what it entails, and how can you be prepared for that. And let me set a little bit of characteristics around the fourth industrial revolution. Right, as I talk about it, it's a technology that is yet to come. It is a very niche space. It is yet to be evolved. It is yet to be I would say it is the framework is yet to be developed, but there is a lot of work that's already happening. So by the time you get out of your engineering institution in the next 4 years or the next 3 years, or even in the next 1 year, if you are a final year student and you are wondering, I don't know what I'm doing, or I do not know what this 4 years taught me, what this 4 years taught you was to set your foot solid on one place, which is engineering. What this 4 years taught you, or what this 4 years is going to teach you, is going to be how you change your mindset and how you start thinking as an engineer. As I was talking to one of my friends, he said, engineering is not a career, engineering is a lifestyle. So you don't work as an engineer, you live an engineer. That's what engineering is all about. So there are many directions in which you could go, right? And I'm not discounting one versus the other. There could be a person who says, okay, I'm not into information technology at all, which I will touch upon in a little while, and I will tell you why information technology is important, irrespective of what your career stream is. Or you might say, okay, I'm not here up for a job. I don't want to work for someone. Let me go ahead. And I have an innovative thought and a very creative thought in me. And I want to apply my engineering skills to that. And I want to build a product and market that. I see an opportunity and I want to leverage an opportunity and leverage that opportunity and become an entrepreneur. So be it. It's a beautiful path to follow your dreams and provide jobs and not be in a place where you just keep doing the mundane things. You might be wired for that. You might be built for that. But what is more important is how do you apply your engineering mindset into what you're doing. You might get into a job. You might get into a job where you start with just developing some code. You do not know the beginning or the end of it. You just do something that you're asked to do. But as you do it, how do you apply your thoughts into it and gather more insights to shape your career? Or you might choose to go on a path of doing your higher studies. You might want to get a graduate education. You might want to do your graduate studies, do a PhD, and you would want to get into research and development too. So in all of those, in all of those, you can still apply your engineering ability. I just wanted to take a pause here and confirm if you are able to see my screen. I'm not sure if someone is able to put a chat note somewhere saying you are able to see my screen or not, but I just wanted to confirm that. Or even if you're not able to see my screen, that's fine. I'll share a copy of this presentation right after this meeting so that you can relate to what I was talking versus, okay, slides are not changing. So I'm not sure what exactly is going on. Technology can sometimes be a hurdle too. Are you able to see my screen now? I think there might be. Sorry, was someone saying something? So I got a thumbs up saying that things are okay and we can move forward. So Revolution 4.0, or what is termed as the fourth industrial revolution, has major components, which is a blend of all of these streams together. So no longer can we separate a computer engineer from an electronics engineer from a mechanical engineer, a mechanical engineer from a production or industrial or civil, so on and so forth. All of these streams blend together. What is more important is how you apply those concepts that you learned as an engineering graduate during your 4 years of education in this. And as I mentioned, that's the difference between what a non engineer can bring to the world versus an engineer bringing into the world. Because you blend the scientific concepts that you have learned along with your creativity and bring up a beautiful product. So, what does this Industrial Revolution 4.0 entail? We're talking about additive manufacturing. And you all know that term might be a little different, but this is something that you've been seeing, that you've been doing on a daily basis these days. It's nothing but 3D printing. We do a lot of 3D printing these days, but how do you industrialize that? How do you bring that into the industries? That's where the next generation of industry is focusing on, making sure that we have all the checks and balances in place to have that infrastructure put in place for even the most complex geometrics and less performing equipments. For example, I'm not sure how many of you read about the recent SpaceX program, and SpaceX is planning on building their one of their core components of their rocket using a 3D printer. A lot of their tools today, a lot of their payloads today are constructed using 3D printing. So there is a lot of evolution that is happening in printing technology or fabrication technology, which I think is going to be very important for everyone to understand, so that number one, we can reduce cost and we can improve performance and make a perfect trifecta balance of complex geometrics and simplified fabrication. The next thing that's really kicking off today is virtual reality and augmented reality. And where is this being used? It's being used in every single industry, especially the industry that I come from, which is more on the transportation side, more on distribution management and all of that, where you have a set of products that are lying there in a specific warehouse. And if you would want to do an inventory rather than a single person going in and marking every single piece that is available in a specific warehouse, you just wear your virtual reality glasses. You just go and use your wearables, scan every single barcode that's there on the product. There's virtual reality that is being used in the telemedicine, in the medical industry, and in biotechnology. There's virtual reality that is being used in doing more complex jobs that require humans to go into certain things and do certain things. How do you do all of that together? And what does that require? It requires vivid imagination on what is the use case or what is the problem that you're trying to solve for, and then how can you actually make it virtual, or how you can virtualize that, in other words, and make it easier for the people to consume it. We're talking about cloud computing. And today, that's one of the core concepts that everyone would want to focus on. Because gone are the days when we had huge data centers that has to be maintained by human beings with hundreds of people trying to monitor every single server and all of that, or it takes days together to put together a single server. That's not the case these days. You just, in a click of a button, you just build a configured virtual machine right there on the cloud, and it is available for use in a matter of seconds rather than in a matter of days. So cloud computing becomes a huge part of this industrial revolution that is yet to come, because it is, number one, easier, it becomes cost efficient, and you lessen the risk of doing operations on your own. Rather, you keep infrastructure as a service, you keep platform as a service, you keep integrations as a service, and you're able to connect all your devices that is linked from anywhere across the globe with the virtual machines that you put in on the cloud. And this also contributes a lot to how you manage your data, both structured data and unstructured data. And where is this becoming more relevant? There were days when you had to write pages and pages of reports, and then you had to run through Excel spreadsheets, access databases, macros, and all of that to get a little bit of intel on how your business is performing. So now we have evolved from there. So we are no longer just looking into the operational data, which tells you what is happening. Now we've gone more into, we've taken it a step forward. We are talking about descriptive analysis. What has happened? Rather than what is happening, we now look into what has happened and what can we get out of it. And then we talk about diagnostic analysis, which is more around why did it happen? If something went well, how did it go well? Why did it go well? If something went wrong, why did it go wrong? And predictive analysis, what is going to happen? So, for all of these to come together, you need all of these other technology that are, which play a huge role in getting and gathering all the structured data and unstructured data. Structured data is nothing but just data points in terms of any numeric data or non-numeric data. Unstructured data could be anything like voice responses. So say, for example, you talk to your friend and you share, hey, I don't think this product is right for me. Then that's an unstructured data, because there is no structure to what a human being thinks about or what a human being talks about. It is pure emotions, it is pure social interaction, it is relational interaction. So those unstructured data also provide uh, a lot of intel into how your business is about to perform. And the other thing that we are looking at when we talk about the fourth industrial revolution is the Internet of Things. And if you take it a step forward, the industrial Internet of Things. It's all connected technology now to make it much more easier. So I'm just going to quote the example from my industry, right? So we have a truck that is starting from a specific point in a specific geographical location. It might take 3 days to reach its destination. But along the way, we have connected devices within the truck which measures what is happening within the truck. How long has that driver been driving the truck? Has he been compliant with what is called as a Department of Transportation regulations? Is he doing anything unsafe? And all of that. And that is all because of the connected devices. And furthermore, let me also bring a different perspective into this. We are talking about an era where we no longer have to keep monitoring certain things. So if you go into core mechanical or electrical engineering areas, every single 3 years or every 2 years, you would go ahead and do a preventive maintenance of either a truck or a construction or an electrical grid or a mechanical equipment or whatnot. But today, with the evolution of Internet of Things, where we would want to reach is how does the machine talk to itself and get information on where the problem is and try to resolve it on its own and give you that intel. So, number one, you're not losing your precious time and money, because every single minute that you spend on something that is non-productive is going to be money that's translated into direct dollars. So how do you leverage these connected devices to understand what exactly is going on and take proactive action and preventive action before that problem occurs? Or how do you put in corrective feedback mechanisms into these things so that it automatically rectifies itself, anticipating something that is going to happen? So there is a lot of things that's evolving on the Internet of Things as well. It just paves way for connected world, both on a consumer perspective as well as on the industrial perspective, and that's what I'd like to term as two different parts, right? So there is Internet of Things on the consumer side, which is more around all the connected devices that you have today, where your tablet is able to communicate with your laptop is able to communicate with your mobile device, and then you have all these voice controlled machines that you are able to use, which controls your lights, your electrical equipment, your mechanical equipment, or anything that you might use on a consumer perspective. But there is also a huge value in taking Internet of Things to the industry. We're talking about autonomous robots. Not all autonomous robots are, uh, I would say, the way in which the movies have represented, right? So the movies represent as if like the in the artificial intelligence world, autonomous robots take control of the entire world and you don't have any control of it. What true artificial intelligence and autonomous robots is all about, helping engineers or helping people who do the job to do it in a much more effective and productive way. Because we've got what is known as an emotional intelligence, which talks about, and I'll touch upon that a little bit later in this conversation. We've got this emotional intelligence, which can pave way for determining what is right, what is wrong, what is good, what is bad. However, we don't have infinite processing power, which your computers can do, processing millions and millions of data points, processing millions and millions of parameters. So, all of that collectively will produce autonomous robots and artificial intelligence, which puts human being in control. It's not that they're going to be in control. Human beings are still going to be able to control, but that paves way for more efficiency and organizational productivity. And not just on a, when you think about autonomous robots, it's not just on a mechanical perspective where you have a robotic arm picking up and dropping product or moving conveyors from one end to another end. We are also talking about robotic process automation, where there could be certain mundane tasks or certain repeated tasks that people do, which would not have to be done by human beings, where they can actually put their time to best use in something else. So that's where robotic process automation comes into play. I'll not go too much into the details on cybersecurity. There's a lot of details that you can cover. Every single one of these individual components need to be secured enough. Uh, there is a there is a lot of talk around how you protect devices. There is a lot of research that is going on into how you can protect your data, your identity, and all that stuff as you go into more of a connected world. So that's where there is a lot of scope. Advanced simulation, you really don't have to do a prototype with expensive materials, with expensive chips, etc. So you do a lot of simulation beforehand, and you are able to do exactly what you're able to do with a physical product. Universal integration, again, as we talk about a connected world, every single thing that we just talked about has to talk to each other. So that's where we're talking about building platforms which would bring all of these together, not just on a data perspective, but also on a hardware perspective, bring all of this together and talk to each other and also provide you essential information. So I just want to quickly move forward and talk about how do you prepare for this industrial revolution, and which is what I term as Engineer 4.0, right? So The engineering or the engineer of the past, or the 20th century or the 21st century, is not the one who was expected in future. And I'll tell you this, and this is a very blatant fact that's prevailing across the globe. And as a person who has been recruiting a lot of engineers, and as a person who had been trying to look out for talent from time to time, one thing that we always get stuck upon is a skill gap. There's a lot of credentials on an education perspective that people come with, but what people miss out is that skill. So, how do you develop that skill? So, there are various components of what is expected in an engineer, right? So, or various skill sets that is expected in an engineer to live up to the fourth industrial revolution, vision through execution. So, the future engineer uh, is expected to be able to transform a vision of an organization or a vision of a company, and transform it and execute it and deliver it. The engineer of the future, as I mentioned to you earlier, is stream agnostic and does not work to be an engineer, rather lives as an engineer, and takes it up as a lifestyle. We're going to be focusing a little bit on the hard skills, soft skills, and emotional intelligence in a minute. And I know that I'm running short of time, and I'll make this quick in the next few minutes. When we talk about hard skills, especially in the post COVID world, this pandemic brought about a huge change in the way in which we do engineering, in the way in which we learn, in the way in which we hone our foundational skills, and in the way in which we hone our skills. So if you look at hard skills, the way in which I look at hard skills is something that you can be trained on. And as I mentioned, the half life of engineering and technology has changed a lot in the last decade, or in the last millennium, or in the last century. Way back in the 1950s and in the 1960s, the half life of a technology was close to 35 years or 40 years. But now they've estimated, based on the latest Delphi study, the half life of engineering and technology has shrunk to less than 3 years, which means by the time you get out of your engineering college, the skills, or what you actually saw as technology or saw as a skill when you started your engineering degree, becomes irrelevant, and there is a new technology that you would have to train yourself in. And that is what is called as upskilling. And this is one thing that I would like to tell everyone that I speak with, my team, the students that I communicate with everyone. Never hesitate to learn. Life, it's a lifelong learning. Life is a journey, and you keep learning in every step of the way. It could be something that you learn from the textbook, or it could be something from you learn from others' experiences, or from your own experiences or your own life. So I don't recruit people for their skill, rather, I recruit people for their attitude and see if they have an ability to upskill themselves. So that's a attitude versus skill conversation. And then once we finish the hard skills, we'll get a little bit into soft skills. I'm not going to be spending a lot of time on soft skills, because I know you would have had coaches who come in and train you on the different soft skills. But I just wanted to touch upon a few of the key soft skills that the industry expects from you as an engineer. And the last one, I will run through what I term as emotional intelligence, and why is it so important as we get into this fourth industrial revolution, and what organizations are looking for in their young recruits and their engineers whom they bring in into their organization. So when we talk about hard skills, the foundational skills that you learn from your college or from your university is very, very important. It might not be relevant to what you're going to be doing because there's a lot of upskill that is going to be happening. There is newer technology that is coming, newer concepts that are coming, newer algorithms that is being built, newer chips being invented. But the foundational stuff that you learn in your college and your 4 years of engineering degree, the textbook skills, the basics never change. The more you focus on your basics now, you don't have to worry about that later because at any point in time in your life, that is definitely going to help. Because your Ohm's law or your Kirchhoff's law is never going to change. Your Newton's law is not going to change. That's the foundation. You cannot talk about relativity without understanding what was Einstein's theory of relativity. You cannot do certain stuff if you really, especially if you want to go more into the core engineering stuff that we're talking about with artificial intelligence, with Internet of Things, with connected devices, and all of that, unless you understand the core or the basics of engineering. But don't stop there. That's what I would want to focus on. Programming is not just meant for information technology students or computer science students anymore. So that's what I've termed here saying programming is now a need, it's not a want. Companies are not like, okay, it would be great if we have an engineer who can do programming. No, we want an engineer, we want someone, we need someone, and in this place who can really do programming. And I'll touch upon that a little bit as to what are the different areas where you can really train yourself on. And that is just a guideline. I want to be very careful when I present this. This is just a guideline. There might be, so 1 year down the lane, if you go and revisit whatever I talked about, that might be totally irrelevant. There might be newer technologies that could have come, but there are certain foundational things that I would really want you to get your hands on as you have this time before you get into the real world. Being agile and more flexible. Need and wants, I'd say needs and wants of consumers and organizations keep changing. They're not the same. As someone rightly mentioned, change is the only constant, right? So how far are we agile? How far can we adapt? How quickly can we adapt to the fast-paced environment that we live in or the fast-paced environment that we work in? Are we able to think and do it at the same time? There was an age where you go ahead to the drawing board, you keep working for days and days together, and then you get to a checkpoint saying that, okay, now I'm ready to go ahead and build a product. Things have changed now. We talk about agile based processes where you go to the drawing board once, you start building what is called as a minimum viable product, and then you evolve, then you enhance that, because what has become more important is the speed to market. You need to be quick in terms of getting your product, in terms of getting your uh, innovation out in the market, rather than lose to your competitor. The third one that I feel is very really important, very much important, is practical ingenuity. What is practical ingenuity? It is nothing but innovation, but I would really want to focus on the word ingenuity because innovation in today's world has taken a completely different meaning because it is becoming more of a marketing strategy, saying that okay, we are an organization which is focused more on innovation. But ingenuity or innovation is a confluence of three factors. Number one, the challenge. There could be an impossible or a daunting task that you might be facing in your organization or in the world. And as you put your mind and thought into that challenge, you struck upon an idea or a clever notion to solve the problem, which makes the world go, oh, that's a clever idea. Wow, that's a really great thought. And there is a huge opportunity. And then you pursue that opportunity in completing and perfecting that solution to a success. And that's what is core or the key skills that the organization is expecting today. There might be more, as I mentioned. These are just the foundational construct of what the industry is going to be expecting from you as you graduate from your bachelor's program, and as either you get into a master's program or you get into a PhD program, depending on what you would want to do, or you get into a job. That's what the industry is going to be expecting. So, what can you really practically do to enhance these basic skills, especially since I do not know the mix of audience that we have here, if people are just from electronics and communication or if there are people from different streams. But as I mentioned in the beginning of my conversation, this is not about the individual streams. We have gone past, we have broken the barriers of the individual streams, and we are now a collective group where everyone needs to understand each other's stream and what their program or what their process entails. So we spoke about a lot of these different things. I just wanted to give a very high level idea on what you can keep reading about, what you can keep thinking about, and how can you develop certain core skills in terms of understanding what these are all about as we prepare for the fourth industrial revolution. Hyperautomation, the automation and artificial intelligence, though old school it might be, still relies on C, C++, and any of the object oriented programming. Artificial intelligence and machine learning, as I mentioned, we are getting into an era of descriptive analysis, diagnostic analysis, and predictive analysis, where artificial intelligence and machine learning play a huge role because based on that predictive analysis, you close the feedback loop, bring in that information to make real time decisions that human beings cannot make to make sure that the customer is being served right. So, focus on Python programming. That's one of the easiest programming languages that I've ever uh, laid my hands on. Data mining, statistical analysis. These might seem like buzzwords, but these are truly not. You might not be able to get into more detailed understanding of any of this without getting a formal education, but there is always materials around you where you can gather and start reading about and reaching out to people who have really done serious research on any of these areas to hone your understanding, to get more understanding, and guide you in the right path. Predictive modeling, data science and analytics. Hone your skills on database querying. Try to understand what the different formats of data is. What are we talking about when we talk about data, and how can you correlate these data, and how do you regress this data, ingress, egress, all of that? How do you bring it in? How do you take it out? How do you visualize this? That is one of the core competencies that organizations expect today. Be it an engineer or not an engineer, that's what organizations want. How do you visualize the data to help you make the right decision on time? Power BI is one of the excellent tools. There are so many other tools that are out there in the market. I'm just giving you certain tools because I know it's easy to learn on them, and the learning curve is much less steeper than a few of the other tools that we see. User experience and design. That's one of the core, I would say it's one of the evolving areas because today customer is king. If you if you make a consumer mad, your company is really going to go downhill real soon. There is an interesting um fact about Amazon. I know a lot of you shop in Amazon, especially with the pandemic hitting hard. People have started acquainting themselves to e-commerce and online shopping and all of that. Amazon released a recent study saying that if there was a page or if there was a product in their website, in their e-commerce site, that takes more than 3 seconds to load or give the user the right information that they need, you lose a customer there because they don't want to keep shopping. They just move on to a different site. So that much is a competition. So just start with the basics on how you leverage CSS, how you leverage JavaScript, be it front end JavaScript or server side JavaScript, or if you're using JavaScript for your middleware, whatever be it, just try to learn a little bit of these technologies irrespective of your stream, because I'm pretty sure that when you get into your real world, into your organization, wherever you work, entry level or mid junior level or senior level or leadership level, these skills are definitely going to be helpful, because the world is moving away from individual expertise to mass expertise, meaning there was a period when there were specialists, and then there was a period again when where there were a jack of all trades who mastered every single skill. And now we are currently in a situation where it is again people are reaching back to specialists, but especially with the skill gap that we see now and the gig economy that is following across the globe post pandemic, people expect you to know more than your core competency, because you are able to really offer more to the organization that you're working on. So that's where it is going to get, that's where you're going to be able to differentiate yourself from your peer. How much of non core competency skills you have as part of your uh, profile. That's that's going to become a huge differentiator. And as we talk about these technology skills, one of the other things that I would also want to mention is about being or staying updated. So, staying updated gives you a couple of different benefits. Number one, it keeps you on top of the world by understanding what is going on in the technology world, what is going on in the industry, where and it also it's a soul searching moment where you uh, try and understand what are the different industries that are there in the world and what do they have to offer. And there are a lot of readily available resources which give you that information. And I'm pretty sure your institution has IEEE membership, your library has a lot of IEEE publications, but there are a couple of IEEE publications that I would really want you to uh, take time and read if you have the ability to do that. IEEE Spectrum. Spectrum is a monthly magazine that you get from IEEE, uh, and it helps you to understand not what is happening today, but what is going to be happening tomorrow. And then Computing Edge is another Computer Society publication. That's again a monthly magazine that comes out, and again that talks about it has got a lot of white papers that gets uh, published. There are a lot of technical journals, certain articles from technical journals that gets published, but there's also what we talk about as coming up in future that you would be able to read on. And if you don't have a LinkedIn profile, go ahead and create a LinkedIn profile. It's a free subscription, and the amount of information and the amount of people whom you are able to network with is enormous. And that's where your relational capability plays a huge role. You are now stepping into a whole new world of communicating online, remote working. I see people who are being onboarded, even fresh recruits from college being onboarded while they are staying at home, being trained from home. So, why don't we get used to it as we live in this era of digital transformation, and as we are someone who is expecting to move into the next generation of engineering and technology? Udacity and Coursera, they offer a lot of free courses, but they also offer paid courses. So there are four steps on how you can stay updated. Identify your passion, identify what you would want to focus on, continue to read on that, continue to apply that. And how do you apply that? It could either be publishing a blog, publishing your understanding on a specific uh, subject, or it could very well be working on something. There are a lot of people who are working on open source software, and they are able to bring in their creativity, apply their creativity, and make sure that they identify their passion there. and then transform the world. So it starts from inside. It's a soul searching moment where you identify what are the different technologies, what are the different domains that are available, where do I want to go? Because I'll tell you this outright, the opportunities are enormous, but we can't be stuck in our shell and say that, okay, I'm just going to wait until someone tells me what to do, because the world is not expecting people who wait on someone to tell them what to do. Rather, pick up the baton and say, okay, I'm just going to keep running. I'm just going to be doing what I am able to do now so that I can prepare for the future. As I mentioned, there are a lot of massive open online courses that you can leverage as well. So I will wrap this up real quick in the next few minutes. Soft skills, as I mentioned to you earlier, I would not want to go too much into the details, but there are a lot of key soft skills that the industry is expecting today, right? Vision and creativity. How are you able to express yourself? How do you might have a brilliant thought. How do you express yourself? How do you tell your story? Do you listen more than speak more? And how do you understand your audience? Do you present to the leadership team who does not understand technology the same way that you do, in a way that they can comprehend and take it up to their leadership? And how do you take feedback and criticism? How do you offer criticism? Are you being sensitive to people and their emotions as you offer feedback and as you offer criticism? How do you react? How do you leverage the emotions that you have and convert them into opportunities, especially amidst a conflict? How do you respond to the conflict? How do you resolve that conflict? So there are a lot of these soft skills. I know that we don't have all the time here to go through every single one of this in detail, but I'm pretty sure that there are a lot of wonderful coaches out there who can really help you to do that. The last thing that I would really want to focus on in the next couple of minutes is talk a little bit about emotional intelligence. I know this is a huge topic, but I'll tell you this: 90% of your career success comes from emotional intelligence. We talked about hard skills. That's something that you would definitely try to learn and acquire your skills, acquire knowledge, make sure that you gather a lot of information and all of that. But there is a unique component, which is emotional intelligence, which is understanding what you are, who you are, and being aware of your emotions. It could be an emotion of joy, it could be of frustration, it could be anger, it could be fear, it could be anxiety. And you would go through a lot of these, especially when you get into workplace. It's not going to be the same always. An emotional intelligent person is not always someone who is happy. He's not a person who is always happy. Instead, an emotionally intelligent person is someone who is able to clearly identify what their emotions are and is able to compartmentalize and make sure that they are able to effectively respond to those emotions within themselves and also with their team or with the people around them. It often determines the quality of relationships that you have, how you handle stress in your everyday life, how well you communicate with others, and how effective you are in your job. Because your emotions play a huge role. And again, as a person who has been recruiting people, I know that more than 75% of the recruiters today, they value the emotional quotient of a person rather than an intelligent quotient of a person. As you might uh, see, there are 12 different focus areas that you can focus on between the four different domains that we have, which is self awareness, self management, social awareness, and relationship management. But there are two main self management um, competencies that I would want to focus on today. Just two of them, and then leave it up to you to go ahead and do some additional reading on what emotional intelligence is. Emotional self awareness. We need to be aware of what state we are in. because that's going to be the key to making the right decisions. And intentionally keep those emotions away from taking rationalized decisions. You might not understand the full extent of this meaning right now, but keep thinking about it when you get into your real world. And you can apply that even now as you do your projects, as you work on a team project. You would still be able to do that. How well do you handle your emotions? And then how well do you adapt to changes? As I mentioned, this goes in line with the agile and flexible quality that the industry expects in future engineers. But your emotions really play a huge role in adapting to certain situations. Sometimes you might be afraid of a certain situation. Sometimes you might be nervous of a certain situation. And being aware of that would help you to adapt to that specific scenario or that specific situation. The last thing that I would want to touch upon is achievement orientation. One of the most important qualities which I really value, and I know a lot of people value, is striving to success. Putting in the right effort at the right time to excel and to strive and become more and more efficient in what we do and what we deliver. And that's what is going to create that difference of what result or how different our result is better than that of what others produce. And as you go grow more into the organization, as you assume more and more leadership roles in the organization, you are definitely going to be learning a lot of these. But this is something organizations expect even in young students, graduate students these days as they enter into the workforce. With that, I'll just close it with just one final thought. Whatever you learn, whatever you hear, take whatever is important for you, but do a self analysis, do a soul searching to understand where you would want to spend your time on. Because the time that you have now is something that you would, I can be rest assured and I can promise you the time that you have now is a wonderful time that you can leverage, put it to fullest utilization. And we are definitely not going to be able to get that time again because I'm experiencing that. I wish I could go back to school again and do the same things that I did when I was in school, not having to worry about things, but keep learning and learning and learning and learning. Today, I take a book to read and I'm not able to read it. I just fall asleep or I'm distracted in a million directions about the work that I've got to do, about the conversations that I need to have, about the presentations that I've got to make, about the story that I've got to tell my business, and all of that. So make good use of the time. I had one more story to tell you, but I'm not sure if the time allows for it. But let me leave you with this thought. When you have some time, go ahead and uh, search for what happened with Apollo 13, which was a third manned mission to space, not to space, to the moon, and how it became the world's successful failure. It's a beautiful leadership lesson. It's a beautiful engineering lesson. Uh, it's it really covers whatever we spoke about in the last 1 hour. Just try to take some time and read through the story. I wish I had some time to say that, um, but I can share whatever I put through as my notes so that you can go ahead and read it at your leisure. But it's a wonderful story of how the team became more agile with change and how they put in their lateral thinking and their basic foundational learning to use when they hit upon a problem, how they were more creative and brought in a practical ingenuity, as I mentioned about the innovation within them uh, to solve a problem that they were facing somewhere 200,000 miles somewhere 200,000 miles above the Earth's atmosphere. And how the team kind of brought in teamwork and resilience and collaboration to solve the problem together. And finally, it was also wonderful to read how the commander of the entire operation uh, put in his emotional intelligence to keep his emotions aside, compartmentalize, and not blame anyone for causing the problem, rather focus on the one goal that he had, which was to return back to Earth safely. So uh, I will read it. I will definitely send it through so that you can uh, take a quick read and understand how things are. And if you're able to get some videos about Apollo 13 and what happened with the mission, it's a beautiful journey. It's an engineering marvel. You will understand how people really work through with their minds in solving a problem, and that's what engineering is all about. I would leave it. I'll leave it here, and I'll open it up for some questions.
Uh, Sir, we received few questions from audience, sir.
Sure.
How to prepare a more professional and skilled engineers?
So I think that was all this conversation is about, right? So, professional and skilled engineers. So when you talk about professional, it could mean too many different things. I think skill is two part, right? As I mentioned, there is hard skill that you can acquire by different sources, from the textbooks that you read, from reading through the different technology and yeah, I would say the evolving technology that is happening across the globe, and how technology is being put into use, especially during these difficult situations, and understanding all of that. But there is also this other part, as I mentioned, about soft skills, where you can really focus more on enhancing your horizon. That's what I keep telling people: expand your horizon, expand your communication. Never hesitate to ask questions. Be inquisitive about why does it have to happen this way. I always tell my team, always ask the question, why not? Why can't I do this? Why can't we do it this way? Because there is no one perfect solution. Every solution can be perfected, but there is no one perfect solution. So, uh, I mean, to be honest, I don't have a very straightforward answer to say how to prepare as a skilled engineer and become more professional. It's it's an intentional living as a professional that you would have to do. And as I mentioned, one of the good things that you can really do if you would really want to be influenced by people is follow people on LinkedIn. There are a lot of influencers, as you can see on LinkedIn. You can follow people who are CEOs of companies, irrespective of boundaries, and you can learn a lot from them as to how they conduct, how they present themselves, how they tell a story, how they talk to people, and all of that. So those are certain non-technical skills that you can acquire. But on the technical side, reading and reading. That's what is definitely going to be helping you to hone your technical skills.
One more question, sir. How to balance emotionally in case of sudden firing from job?
Yeah, that's a very difficult question to answer, especially a person who has not been fired, and I had to make certain difficult decisions in the past where I had to let go of certain people. But one thing that I always tell the people that I let go is, you might not be a fit in that specific place where you are, or where you are being let go of, but you're definitely going to be a fit somewhere else. So all that we need to keep in mind is not to lose hope. And that's the unique quality of a human being, because you are still able to face the world with the hope of tomorrow. Because as I mentioned, the opportunities are enormous. The job that you are currently in is not the only job. And I might be here in this position today. I might be let go off tomorrow. How do I handle it? Probably I might have to tell to myself, okay, that was an organizational decision, which was good enough, and I think I can serve better. So keep in mind that the opportunity that you might have ahead is going to be much better than the opportunity that you just left behind or that you were let go of, and that is going to make all the difference. And see what was the reason behind you being let go of, or what was the reason behind you being fired. Was it because of your lack of ability, or because of your lack of skill, or was it a mismatch of expectations? And try to learn from that and apply that learning to your future job. And as I mentioned, the opportunities are definitely enormous. It might look like I would say a small hiccup at this point in time, especially because of the current pandemic situation. But even then, the economy across the globe is still booming, and especially for engineering and technology, since the world is turning more towards technology, automation, and all of that stuff, there is a lot of opportunities. It is just making sure that we set our minds straight and we focus on the goal, and upskill ourselves and be ready for the next opportunity at hand.
One more question, sir.
Sure.
How can budding engineers get over the myth about lack of job opportunities for engineers in India?
Um, I got to be honest, I do not know the current job situation in India, but I know that there's been a lot of manufacturing and uh, manufacturing and engineering jobs that were curtailed, and there were not a lot of jobs available. But that's just a temporary hiccup. I think entry level jobs are still there, especially if we are able to, and that is where sessions like these, webinars like these, are definitely going to help you, right? How do you get an exposure of an external world? What is happening in the outside world? And how do you upskill yourself? I think upskilling is a key term here. There's definitely talent. As I mentioned, there's 80% of jobs that could not be filled in engineering and technology because they are not able to find the right match. There is a huge supply of engineers. There is a huge demand of engineering jobs. However, these two could not meet together, and the key factor being that skill gap. And if you find out a way to understand what your skill gap is and upskill yourself to match that need, you would definitely not sit in this 80%. You would sit on the right hand side of that 80% where you are able to get a job quickly, because the world is ready to embrace creative talent. Really, someone who can think out of the box, who can think laterally and not in the way in which the world goes towards, but who can think outside of the box. So I would say, don't worry about what is yet to come, because as I mentioned, we do not know what is going to come up in the next 1 year or 2 years or 3 years. But by the time when you step out of your institution, the hope and the confidence that you may need to have by acquiring these skills is like, okay, I can go conquer the world. And again, there's this entire factor about trusting in God and the supernatural, and the belief system that we have for all of that, which is very important. But at the same time, we need to keep doing what we need to do to prepare ourselves for the outside world as well. I know I might not answer your question directly, because I've got to be honest here. I'm not very much aware of the job situation that is currently in India. I'm just looking at it globally, and definitely there is a lot of opportunity.
So thank you so much, sir. Thank you for your detailed and mind-blowing speech, sir. Really, your speech satisfy our young budding engineers to handle their critical emotions. Thank you, sir.
Thank you
Uh,
so much. Thank you for
you
the
want to
opportunity.
become a thank you, sir. You want to become a better person? Just give thanks. Now I call upon Mrs. M. Chitra Evangeline Christina, ma'am. Assistant Professor, Department of ECE, to deliver the vote of thanks.
Good evening, one and all. I consider it a great honor to propose the vote of thanks on this occasion. First of all, I thank Lord Almighty for helping us to conduct this webinar in a successful way. Next, I thank the resource person, Mr. Barnabas Muthu, technology architect from Ohio, US, for sharing his knowledge and expertise on this field. We have many takeaways with us as engineers. Thank you, sir, for giving us the industrial expectations in nutshell. We need. We actually had an excellent session, sir. I feel happy to thank Mrs. Priska, HOD of EC department, for her continuous motivation and the coordinators, Francie ma'am, Chitra ma'am, Niranjana ma'am, and all the staff members of ECE for the contribution. Thank you, team. Last but not the least, I thank all the participants for being a part of the session. Without you all, we can't imagine our success. Thank you, one and all. Once again, thank you.
Thank you, ma'am. Dear participants, the feedback link for this webinar is given on the chat box and description box. Please fill the form with utmost care and you will get your certificate within 3 working days. And don't forget to subscribe our department YouTube channel, FX YouTuber, to get up-to-date information about the forthcoming events. Thank you all. We shall meet you soon with another informative webinar. Once again, thank you all.